Hello and welcome to Batchman, where today we are going to discuss special right triangle. So there are two types of special right triangles, 45, 45, 90, and 30, 60, 90. For the purposes of today's video, we will be focusing on 45, 45, 90. So right off the bat, when we're dealing with special right triangles, we do have to be able to identify them. And we identify them based on the angle measures. We do have to have that right angle. In this case, we have to have 45-degree angles to go with it. Lucky for us, we know if we have one 90-degree angle and one 45-degree angle, that the other angle, whether it's given to us or not, in our triangle must be 45 because the sum of all the interior angles must equal 180 degrees. So that is one of the reasons why for this case, we don't have to have all three angles labeled, just two. 45, 45, 90. Another thing I want to draw your attention to, notice over here, I have two samples of notes. Since in this video, we're only talking about 45, 45, 90, I am going to cross out those 30, 60, 90 triangles. Notice I've given you two formats that you'll see this note in. One defined with X, and then a reflection for that triangle defined with A. They are oriented slightly differently, as important. But it's important that we get used to seeing these triangles oriented in a variety of ways. One of the reasons I brought up two resources with two different variables is to show you that if your problem gives you an X, it's going to make it really confusing if we use the X version of this formula. Why? Well, I'll show you why. In this case, our figure provided that we're trying to solve for, they labeled the hypotenuse x there. We're trying to find x. But in both given figures, notice the hypotenuse is actually square root of 2 times the variable x, where x is defined as a side length here. All right, where x is defined as a side length. In other words, x doesn't mean the same thing in this figure as it does this figure. And that's important. So that's why I recommend my students to get comfortable with seeing this in two ways. So if you'll notice in this figure, we label the hypotenuse as a square roots of 2. Well, that's okay. We can see that x equals a square roots of 2 here. That's good. So that tells us to find what the x hypotenuse is. We have to figure out what a is. Based on our notes here, a is the side length. Our side lengths, the legs that are opposite our 45-degree angles there, across from our 45-degree angles there. So in this case, if we were using x, then y would be x, and then x also means this, and it just gets complicated. So we know y is equal to a. But good news in a 45, 45, 90 triangle, both legs are the same. That means this is also equal to a. So right off the bat, we can start filling things in. We know y has to be, because it's equal to a, y must equal, that's 3 square roots of 2 over 2. So I'm just going to copy that over, make our lives easier. And we're going to plug that same a in over here. Same a, substitution. And I'm going to show that work down below here because it is a little more complex. So we're going to see that x is equal to a, where a is equal to 3 square roots of 2 over 2 times square roots of 2. Because this is a fraction, I'm going to go ahead and make this a fraction. I like multiplying fractions by fractions. We can make any number a fraction by sticking it over 1. Radicals have this property that if you multiply a square root of 2 by a square root of 2 like that, the square roots just go away and we're left with 2. So this is 3 times 2 over 2. We can simplify in a variety of ways here. But I'm going to go ahead and go away. These 2's cancel. So we know x must equal 3. In this case, that means our hypotenuse is equal to 3. All right, and there you have it. We have solved for the unknown variables and a special right triangle. Oh, I almost forgot something important in mathematics. X and Y are lengths, and lengths are given in units. Now, in this particular problem, they did not give us units, but if you are on certain exams, they might actually count you off if you didn't put the words units at the end of here. Now, if you were given inches, then you put inches. That is important. But if you're not given units at all, and we are finding a length, a distance, we technically need to put those. X and Y are now solved for in a 45, 45, 90 degree triangle. Thank you so much for your time.